one and all. This is 2938 separate black and white balls. Okay, so that's a pretty simple problem. It just requires you to more or less recognize what something means in terms of where it starts and where it ends up, right? Sometimes in these problems, they seem like they're super complicated, but then when you actually just break it down into, okay, this is what I'm given, and this is what the result needs to be. What I'm given, what the result needs to be, what needs to happen in order for what I'm given to turn into what I need the result to be. And sometimes I can greatly simplify the problem. So sometimes when you're looking at these problems, think about the input and the output. And if it's something where things are moving around, it's like, what would it take to get this from this situation to this situation? Super abstract thing to say at the introduction of a video, but it'll make sense after you read this problem and then utilize that observation to greatly simplify what you need to do. Okay, so there are n balls on the table. Each ball has a color, black or white. You are given a zero index binary string S of length n, where 1 and 0 represents black and white balls respectively. Okay, one thing to notice about problems sometimes, I mean, technically, yes, you're given a binary string, but this isn't like a binary string problem, right? Sometimes they'll use terminology which can be a little bit confusing because it'll lead you to conclude like, oh, this is a binary string problem, right? Or this is a binary search tree or binary this or it's like, no, that's just a cute way of representing what you're given, but this is not that kind of problem, and there's nothing within the description of this problem that would indicate that, right? But it just says the word binary string, okay? Because, you know, if it's 1, it's a black ball. If it's 0, it's a white ball. Okay. In each step, you choose 2 adjacent balls and swap them. Return the minimum number of steps to group all the black balls to the right and all the white balls to the left. Okay, so you're basically given all these balls, right, in different orientations, and you're trying to figure out, like, okay, I need to move all the white balls over here, and I need to move all the black balls over here, and in order to move them, I swap them, right? And each swap that I do is a transaction. Now, this is one of those annoying problems because, you know, the examples aren't that beefy, right? You don't want an example that takes forever because you're going to, you know, it's going to waste a considerable amount of your interview just trying to solve through the example. But you also don't want an example that reveals nothing, because that example that reveals nothing will reveal nothing to you about what the solution is like. So let's try something else. Okay, so there, you know, these examples is simply right here. You have a black ball, a white ball, and a black ball. So you want to get the black ball over here. So you swap this 1 and the 0. You get 0 and 1. Here you have a black ball all the way to the left and all the white balls to the right. So you need to swap them. So you swap this black ball, swap this black ball. You get 0, 0, 1. And then here, everything's already in the right position, right? Your white ball's already way to the left, and your black ball's already way to the right. All your black balls are to the right, so you return 0. Now let's try a little bit more of a complicated solution example, right? So let's say for an example, say we had the black balls here or something, you know, I don't know. And then let's say we had a few white balls in these positions. Is that visible? All right, so you have white balls in this position, black balls in the other position. So what can be done in this situation? Well, we can move items accordingly, right? So if we have a white ball here, right, we can swap it. So let's just go through this whole process of swapping balls. So the first thing I'm going to do is I'm going to take this white ball and move it to the left. And then I'm going to move the other white ball to the left as well. Okay, now I'm just going to kind of do this in a weird way so it's quicker to write because I don't want to be swapping between colors. Right, but you can see the transactions here, right? And this is why it's referenced as a binary string. Right, you have this 0, 1, this 0, 1. I swap them here. And then I start swapping this white ball to get it over, right? And that takes 4 transactions, right? So the answer to this is 4. Okay, and one of the beautiful things about Leetcode, it depends on your interview, right? But, you know, you can always put in what you want as your example, just to give you an opportunity to verify that your understanding of, you know, working out the problem manually makes sense, right? So we have 1, 0, 1, 1, 0, 1. All right, and I said that the answer was 4. All right, so hopefully we get the same thing here. So I'm going to get it wrong because so 4. So that makes sense. So this is maybe not the only solution. I don't know. You know, we have to have a conversation about that, but this is one such orientation to this problem. Okay, so this can be kind of difficult because you're like, okay, you know, the first thing this might lead you to believe, if you don't fall for this idea of, oh, it's a binary string, there's something binary about this, right? Because it's just about the representation, it's irrelevant. Is you might be lean towards like some sort of dynamic programming solution, right? Because you're like, okay, if I swap something with something else, what does that mean? Maybe this swap here, this is the best swap given this situation. Well, if I swap here, now I'm in a different state. But the problem is actually much simpler than that, okay? And the problem is much simpler than that for one reason. Since we're trying to, the reason is we're trying to simplify. We're trying to minimize the number of swaps that we do, right? So I would never want to swap a 1 with a 1. Okay? Nor a 0 with a 0. I don't know why I typed out whatever. Okay, and why that's important, right, is because, well, you know, what does that give you? Okay, let's just say, for example, you know, just to kind of prove this point here, right? Well, let's say we had 0, 0, 1, 1, 0, 0. I'm trying to minimize the number of swaps that I do, right? So if I have a 1 and a 1, and I'm like, okay, I'm going to swap this one and this one, what does that give me? Nothing but the same thing. I've just wasted a swap, right? If I have a bowling ball and a bowling ball with the same color and I swap them, it doesn't change the picture at all, right? I haven't improved this situation at all by swapping this one with this one, right? And you'll notice here, I never swapped a 1 with a 1 or a 0 with a 0, right? When I get to this case, for example, when I swap this 0, there's no point in swapping this 1 with a 1 because it's not going to change anything, right? It's only going to leave me in the same situation. So I should never swap an element with the same thing, okay? And the reason why that is so helpful, I mean, it seems pretty obvious as well. If I'm never going to swap a 1 with a 1, then things can only end up in one place, okay? Because what's going to happen is it's going to move over and it's going to have a slot that it needs to end up in, right? Basically what I'm saying is, you know, this 0 here in our example, and let's write out our example again just to make this clear, right? This 0... This 0 is going to get put in the first slot, right? It's going to go as left possible. And before I even finish this problem, I know that this 0, since it's not going to swap with the other 0, it's going to get stacked next to the closest 0 it's going to be next to. It's going to end up in this slot, right? If I have 1, 0, 0, 0, 0, 0, 0, this 0 is the first 0, so it's going to end up in the left spot. This 0 is the second 0, end up in the next spot. Let's try it a different way. I'm really trying to make this point clear, and I don't want to mislead you into thinking something else. Right? When I look at this problem, I know that the final result will be 1, 0, 0, 0, 0, 0, 1. Or, I guess I don't know what the final result will be. I'm all over the place today. 0, 0, 0, 0, 0, 1, 1. Right? That'll definitely be the final result. Okay? But since I'm not swapping any of the 0s with 0s or 0s with 1s, I know for a fact that it was this 0 that ended up going here. Right? And I know it was this 0 that ended up going here, and this 0 that ended up going here, and this 0 that ended up going here, and this 0 that ended up going here. And I could say the same things for 1s, right? This is the one that ended up going over here, and this is the one that ended up going over here. Right? Because I never swapped the 0s, and I never swapped the 1s. So the 0s are going to get put as far back as they can go until they hit a 0, right? And they're like, okay, now you're in your right spot. And since I never swap them, that'll be the fastest way that I do it. Because if I do swap them, it's not going to improve my score. It's only going to make it worse, right? Swapping a 1 with a 1 or a 0 with a 0 isn't going to change anything for me. It's not going to help me, right? So when I'm looking at this kind of case, when I look at the initial problem, I know the distance that everything needs to go in order to make this work, right? When I look at this first 0, I say, okay, this is the first 0. All right, and maybe we'll walk through it like that, okay? So I'm going to move this over, actually. And I'll rewrite this problem out. Let's do the initial example, actually. All right. So the number of 0s that I've seen and my score so far. Okay. So when I'm looking at, I have 0, score, 0, 0. Okay. When I'm looking at this 0, it's the first 0. So I know it's going to go to the very left. So how far does this thing need to go? So let's look at the index I. 0, 1, 2, 3, 4, 5. So this 0 is at position 1. How far is it going to need to swap in order to get into the first position? It's going to need to swap 1 position, right? It's going to be I minus the number of zeros so far. Right? So when I move this over, it's going to cost 1 because I is 1 and there's 0, 0. So that's going to cost 1 to move it over. So I'm going to add 1 to my score, and now I have an additional 0. Then I look at this 1 and I say, I'm going to ignore these 1s because I'm only going to think about moving the 0s over, because that's the same thing as moving all the 1s over, right? If I have 0s and 1s and they're just mixed together, if I move all the 0s to the left, if I push all the 0s to the left of all the 1s, well, then all the 1s will be on the right, right? So I don't need to worry about what happens with these 1s. I'll just keep this walking through. I look at 1, I say 1 again. Now I look at this 0 and I say, okay, here's where it gets kind of interesting. You can see the point here that I'm trying to make, right? So this 0 is at position 4. And where's it going to end up? Where it's going to end up all the way over here, right? Because that's going to be the next one the next 0 we're going to place, right? Because I've already placed the 0 in my mind. I've said, okay, I've accounted for the fact here, right? I've accounted for the fact that I'm going to move this 0 over 1. So now I have the first position is where the next 0 is going to go. Right? So this is 0 positions where the next one's going to go, the next 0 is going to go. So this 0, how far is that going to take? Well, it's at position 4, and it needs to get all the way to position 1. An additional 3 steps, 3 plus 1 equals 4. And then this is the same, 2 and 4, and then I just return this. So hopefully that makes a little bit of sense what I'm doing here, right? What I'm basically saying is, okay, I'm kind of thinking about how I'm building this final string, right? Basically saying, okay, I look at this 1, I'm going to ignore it because I know it's going to get swapped at the end. I look at this 0 and I say, oh, I'm going to have to move that 0 over. So I'm going to put it in my final string, and I'm going to say, okay, now my new open position is 1 here, and it cost me 1 to do that. Then I look at this and say, okay, something else is going to swap with that to move it over. Something else will swap with that to move it over. Then I look at this 0 and I say, okay, this 0, it's going to take 1, 2, 3 positions to put it in this slot. 3 positions to put in this slot, so I add that to my score, right? Plus 1, plus 3. And then I look at this and I know it's going to get swapped over, right? And at the actual, I don't need to actually do the swaps with this to become 0, 1, swaps with this to become 0, 1, swaps with this becomes 0, 1, and just like that, right? 3 swaps it got over, and if you see the actual string. So it's kind of built into the actual calculation, right? I don't need to actually do the swaps. I just need to know that, okay, that's the number of swaps that I would need to do. And implicitly, knowing the number of swaps will capture the fact, right? Because every time I move the 0 over, I'm pushing all the 1s to the right, okay? So all we have to do in this problem, right, is keep track of the number of 0s we've seen so far. That way we know where the next pointer should go. And every time we see a 0, we know, okay, that 0 is going to get moved into that new slot, okay? Hopefully that makes a little bit of sense. Not my best video, guys. I do apologize. I quit caffeine. Well, I quit drinking soda, so I only have access to caffeine in the morning when I drink my coffee. So then there's this, prolonged delay where usually I'd have this kind of consistent digestion of caffeine throughout the day by drinking soda. Now that isn't the case, so there's definitely a bit of a mental cognizant compute failure, right? The engine's not running on nitrous anymore. Okay, so let's go ahead and code this in, right? So we want to keep tracks of the number of 0s, and we just call that 0s, but let's just call that, I don't know, O's, 0s. And then we'll call the other thing our score. Terrible code, I don't care, okay? Score, O's. Zero, 0. So we look at each I in the range. Okay, this is causing considerable compute failures because it has to spend additional compute to render my tablet, which isn't even being viewed. So for I in range, length of S, we're going to say, okay, well, if the current thing we're looking at, S of I, is a 0, well, then we're going to have to move this 0 over. So where's this 0 going to go? Well, I'm going to have to swap that 0 over all the way to the new position of 0. So that'd be 0, I minus 0. Now I move over the number of zeros that I've seen, and now I move over this, and I just return S of C. Okay, so basically, what happens is, right, we look at each element and its index, and we say, okay, this thing's a 0, so now I'm going to have to move it over. Okay, so when I move it over, I basically say, okay, S of C, well, the current position of it is going to have to go to where the new position of it's going to be, right? This is basically the new position, the number of zeros, right? Because the number of zeros that I've gotten so far, I've already filled those slots, so now it's going to go in the newest available slot, right? So the current position minus where it's going to be is the difference. So that's the number of swaps that I need to do. And then now I've just added another one, so now I increase kind of to the new slot where I'm going to go, right? And maybe it'd be beneficial just quickly before I submit this to see, you know, kind of the trivial example, and that'll show you how this slot idea really works clearly, right? So here, let's look at a trivial example where it's 0, right? So 0, 0, 0, 1, 1. All right, and we have zeros and we have score. So zeros, remember our I is 0, 1, 2, 3, 4. This is the index. All right, remember what here? So 0, this 0, okay, we've encountered a 0, so we need to move this 0 over. Well, how many places do we have to move it over? Where zeros is 0, so 0 minus 0 is 0. So I add 0 to my score, and now after this I have, I'm trying to remember how I updated this. Did I update it after I saw a 0 or before? Okay, 1, that's fine. All right, now I'm here, and I have a 0 again, and I say, okay, this 0 needs to be moved over. Well, it needs to be moved over to the position where it's going to end up, where it's already in the position that it ends up, right? So that means the difference is 0. So the position that it's at minus the position it will end up, the number of zeros, 1 minus 1 is 0. So I add 0 to 0, I get 0. Now this is 2, and it's just the same thing over and over again. Right now this 0, I say, okay, this 0 needs to be moved over. Where does it need to be moved over? What actually is in the position where it's going to end up, right? So 2 minus 2, 2 minus 2 is 0. And now I have 3. And then these things, again, these are implicit, and then you get this final score of 0. And maybe I'll show you how this works. So this is, this calculation is this. Or we take the current index that it's at, and we subtract it by how far it needs to go. Because we have a 0 here. And here we have a 0, so look at the index that it's at, and how far it needs to go. Really just trying to add color here so the point is clear. And there you go. All right, and this one, technically it'd be the same thing, right? So this is 0, nothing, but you know, this 0, 1 minus 1, this 0, 2 minus 2, this 0, 3 minus 3. Because the zeros tell you the position that you need to be at. All right, hopefully that point is clear. I've pretty much exhausted everything that can be said about that at this point. All right, I'm trying to just get a good picture for the screenshot. I do apologize. I know it's kind of annoying. All right. So with that said, let's submit that. Having variables with capital letters is the first thing. My boss would kill me, but that's okay. All right. That's why it's beautiful Leetcode, because you make your own rules, you know, because this code goes nowhere, means nothing. All right. All right, so what is the run and space-time complexity of this solution? The 52 thing is weird. I wonder, I have no idea. Is there a faster solution to this? This seems kind of weird, this half. If there's a faster solution to this that you know about, like a log n or something, maybe there is a binary thing, I don't know what I'm talking about. Let me know. I love being wrong, because that's an opportunity to learn. All right, so let's say n is length of s. So time, well, we gotta what? We gotta, we have to we make these two things as constant, and then we look at every character in the string s, right? So we look at all the characters, we do a constant operation, constant addition, then we return just that value. So we look at n things and do constant things. So for all n things, we do something constant. That's n constant things. That's O of n. All right. For space, well, we just create these two variables, and independent of the number of things that we're looking at, we're only ever going to create these two variables and update them accordingly. So that's constant space. All right. All right, everybody. I hope you have a beautiful rest of your day. Happy whatever day you celebrate. You notice this little guy because it's la día de acción, well, not la, el día de acción de gracias esta semana es el, va a estar, no sé, el jueves de esta semana. Vamos a celebrar, vamos a hacer una celebración, vamos a comer mucha comida, cosas como esa.